Hit the red button or not necessarily? Oh, it's okay, cool. Thank you. All right, who's going to help me here? Okay, and the answer is 6.6. Nice. Okay. So now what we have done is we changed this matrix to this matrix. These are one and the same. So we started off with 10, 4, 4, 12 times I1, I2 equals 6, 9. This is of the form AX equals B. And what we have accomplished now is we have converted this into what's called as U. U stands for upper triangular matrix. Okay. All right, what does the upper triangular matrix look like? 10, 4, 0, 10.4, I1, I2 equals 6 and 6.6. Okay? So this is U times X equals modified matrix. Let's say we call that B or C, whatever. Okay? Now can you use matrix equation and write these as equations for me, please? Matrix multiplication. Can you multiply these two matrices and tell me what the left-hand side is? These two, just multiply. 4I2 equals, okay? 10.4 I2 equals 6.6. Can you, from these two equations, find out what I2 is? Let's do that. Could you do that on a calculator, please? Okay, and then we will go back to the first equation. We will say 10 times I1 plus 4 times 0.6346 equals 6. And that'll give you an I1 equal to? Nice, right? So you have done this at high school, but you did it in a slightly different way. So how did you do it in high school? You'd multiply this by 10 by 4, right? That way you cancel this out? And okay. Okay, so, but do you understand how this is done now? Yeah? You want to do another example? The same thing? The book is confused.
Solve for I1 and I2 is the eliminator.
Yeah, the elimination way, yeah. All right, so there's another way to solve it as well. We'll do that as well.
So there's the
The row picture and the column picture are for perception, visual understanding. It's not to get the answer.
But you can get the answer.
You could get the answer if you're accurate enough. Yeah.
I think we did learn it in high school, but it was different. It wasn't like that. It was more like, for example, 2x plus 3y is equal to, I don't know, 5, and then under that we have, yeah, something like that.
Yeah.
Oh, that's what we're doing?
Yeah,
Yeah.
that's what it is. Because I remember the elimination and the combination thing.
Yes.
There's
See,
like other ways to solve it, right?
yeah, the substitution method works beautifully, but the problem is it works only when the matrices are small. What happens is in engineering, you're going to have a million by million matrix. And substitution is just very, very time consuming if you were to do it in a computer.
Isn't it for like, if it was regular algebra, wouldn't you put it like, one of the equations equal to y and then plug that in for y?
You could do the same thing. So let's say we have an equation like this, 2x plus 3y is 5. And I'll say 3x plus, 5y equals 2. Then what I would do is I would take the second equation here, and I would say y equals 2 minus 3x divided by 5. And I will put that back into this equation. And I will say 2x plus 3 times 2 minus 3x divided by 5 equals 5, and solve for x, and then solve for y. We're doing the same thing. So we call that substitution. We call this elimination. Okay? So we can solve by substitution. So the different ways in which you can solve are, you could solve by substitution, which is very high school. We won't bother with that. The second one is elimination, which is very commonly used in engineering practice. When you work as an engineer, a lot of the work that you now do on paper and pen will be done by computers. And a lot of these computer programs use a program called as Gauss elimination to do exactly what we did here. We convert the matrix into an upper triangular matrix and then work our way from the bottom to the top. Okay? That's state-of-the-art computational technology for solving a lot of engineering problems. That's elimination. So we have substitution, we have elimination. We have another method called as inverse, which I'm going to talk about right now. Okay? And then these three will help you calculate the number, and then you also have the row picture and the column picture. Which you can call as graphical method for finding the solution.
How do you choose what a pivot is normally?
You go along the diagonal, okay? And the goal is you pick the first number and make everything else 0 below that. Because what we would like to do is, you see how this reduces it to one variable? That's what we want to do. So let's say we start with the 3 by 3 matrix, right? 1, 2, 3, 3, 4, 2, 2, 1, 7. What you would do is you would take 1 as a pivot, make these two go to 0. You would take 4 as the next pivot and make this go to 0. Okay? And then finally you would take this as the pivot and make everything else here below go to 0, if there are more here. If not, you'll stop here. So what happens is these two numbers are 0.
So it's always the upper leftmost number?
Go along the diagonal and convert everything below that number to 0. That's the concept of a pivot. Okay? The idea is to completely erase the bottom half of this triangular matrix. So you can think of a matrix as diagonal plus 2 triangles. Okay? So when we say U matrix, that's an upper triangular matrix, which means all the bottom 3 are 0. You have the diagonal and non-zero above that. We call that a U. If it were the other way around, we would call it an L. Yeah.
So for example, with the, so the pivot can never be 12?
The pivot can be 12. So let's say I had another row here, 3 and 7. I would take 12 as a pivot and make this go to 0. I would take 10 as a pivot and make these two go to 0. So pivot goes along the diagonal, and then you make everything below the pivot 0.
About the upper right
let's make that a pivot. It's not going to be quite the pivot the way in which you're used to, but let's do that. So the third step is calculating the inverse. So I might be going a little bit past your book. So forgive me if I do, but this is for fun. You'll enjoy this.
Did he say that the 4 can be a pivot?
Not a pivot, but let me show you what I'm going to do with the 4. Right? So let's talk about the third one, which is called as the inverse. Okay? I think I'm teaching you on Wednesday as well for the lab. So if we don't finish what I would like to do today, we can take some time on Wednesday and do this. And if you want me to do it again, I'll be happy to do it as well. Okay? All right, so let's do the third method, which is calculating the inverse of the matrix. So you see how this 10, 4, 4, 12, I1, I2 equals 6, 9. We typically call this as AX equals B. A is the matrix, X is the vector of unknown quantities, X, Y, Z, or I1, I2 in this case, and this is the right-hand side B. So if I wanted to calculate, pretend this is an algebraic equation. It is an algebraic equation, but pretend it's just AX equals B. If I wanted to find X, what would you do? If I have the product of two numbers equals to a right-hand side, if I wanted to find X, how would you do it? Divide by A. So in matrices, we don't call it division. We would say A inverse times B. All right? So the question is, what is A inverse? I'm sorry? A inverse? Yeah, we'll talk about A inverse. Did you do it in high school? No? How come you're starting the homework already? Oh, okay. You're just thinking ahead? Oh, okay. Well, we'll do it. Linear algebra is very simple. The reason why I say it's simple is because it's very methodical. And as young undergraduate students, when you have a nice procedure, it makes understanding so much more easier. There's nothing vague or uncertain about it. There's beautiful procedure for everything, and it always works. And you can always check your answer. And I'm also going to show you how to do all this using MATLAB, so you can compare your answers and check, and you can get instant gratification from this as well. Okay, so let's do AX equals, let's calculate the inverse. So I have 10, 4, 4, 12, and I'm going to augment it with 1, 0, 0, 1.
Why?
I will tell you why after we're done. Okay? I'm sorry? You do? Okay, cool. All right, let's do this. I'm going to, give me 5 minutes, I'll give you the answer. I'm going to, this is A, and this is I. Okay? I'm going to perform a bunch of row operations to convert the A to an I. Okay? And what will happen to the I is it will become A inverse. Okay? So here you will end up with 1, 0, 0. You want to change this into this. And in the process, you would do whatever you do to the left-hand side, you're going to do to the right-hand side, and this will become A inverse. Okay? Now let's see how we can do this. So what's the pivot? And what's the multiplier? 4 over 10. Okay, what's the row operation? Row 2 equals row 2 minus m times row 1, which is nothing but row 2 equals row 2 minus 4 over 10 times row 1. Okay? So what do we get? Row 1 remains unchanged, 10, 4, 1, 0. Okay, what happens to row 2? Four minus 4 by 10 times 10, which is 0. Right? We did this before. I'm just repeating it again. Okay? And how about this one here? 6. 10.4. How about this one here? Row 2 equals row 2 minus 4 by 10 times row 1. So that'll become negative 4 by 10. And this will become 1. This will stay as 1. All right, so pause and see if you understand this. So row 2 equals row 2, 0, plus 4 by 10 times row 1, minus 4 by 10 times row 1. So it's 0 minus 4 by 10, that is negative 4/10. Okay? Yeah. We're doing this operation to the entire row 2 here. So this one here is 4 minus 4 by 10 times 10. So that becomes 0. 12 minus 4 by 10 times 4. That is 10.4. 0 minus 4 by 10 times 1. Now, I'm not getting good feedback from you guys. Yeah, how about I write down each entry here? That'll help. How did I get this one? Okay. How about this one? Four over 10 times 4. How about this one? No, what are we doing? So we're going, which is negative 4/10. Which is 1. Okay? You okay now? Good. All right.
First row, use one thing and never change.
No, we're going to change the first row because we want to make this become like this. All right? So what's the next number you want to turn to 0? This is positive 4, right? Not negative 4. So we want to change 10,441 into 1001. So we made this 0.
So you have to make the 4 0.
Yep. And what is the pivot for that? Pivot's always along the diagonal. Yeah. No, that's gone now. That doesn't exist anymore. So we have to deal with this. What about the, which one? This one here? We have to make 10,441 to 1001. So we made the 4 into a 0. We will make this 4 into a 0. We will make 10 into a 1 and 12 into a 1. We'll do it.
Is it the reason why it's 1 0? Is it because if it's a pivot, it's 1? And then when it's.
No, pivot is not 1. Here the pivot was 10. And now the pivot is 12. we would like to make the numbers below the pivot go to 0.
And that is why there's 1, 0, 0, 1. Because it's
No, oh no, this we start with this. So my statement that I'm not justifying is, if I have A and I, and if I do a bunch of row operations to make A become I, I'm doing the opposite to I and making it A inverse.
So now we start with 1, 0, 0 instead of like 1, 1, 1.
Okay, the reason why we do that is, so when you have two matrices, A and I, when you take the inverse of the product of matrices, the answer on the right-hand side equals the product of the inverse. So A times I whole raised to the negative 1, or inverse, is nothing but I raised to the negative 1 times A raised to the negative 1. So if we start with an I here, and if we make this as A, make this into an I, this A will go the opposite direction and it will become A inverse. I will become A. So if you make A, if you do a bunch of row operations to make A become I, you're doing an operations to make I become A inverse. Okay? Okay. In your junior year, I teach this course and I'll give you some more explanation. We come up with elimination matrices, and when we multiply all these elimination matrices, it gives you what's I. So I'm not quite giving you the honest-to-goodness answer about why I start with A and I. But at this stage, believe me that if you start with A and I, and if you make the A go to I, the I will become A inverse. Let's leave it at that. Okay? So I'm not able to give you a satisfactory answer at this stage just yet.
Okay, so what if you switch the 10 and the 4? If it was 4 and then 10 instead of 10 and 4, would that be? Huh?
Not a problem.
That
If
would
I
be
were to
0,
start,
1, right?
if I were to start with this, 4 and 12, 10 and 4,
Wouldn't that be
and 0, 1, 1, 0.
Yeah, so it has to do something about.
Yeah, I can take that and convert that too. That's fine. Both are
Doesn't
fine.
it depend on the pivot then?
I'm sorry?
It's like-
Yeah, you change the pivot. Now 4 becomes the pivot. Your multiplier becomes 10 over 4
but isn't-
instead of 4 over 10.
But isn't the reason why it is 0, 1, 1, 0 is because 12 and 10 could be the pivot, and then all the other ones are under, like below the pivot.
The pivot is always the diagonal. Whether you switch the row or not, it doesn't do anything to the outcome. You can swap rows, and it has no effect on your answer. So imagine the row picture is nothing but two lines intersecting. If you made the first row the second row, do you change the row picture? Right? Row picture is simply each row represents an equation. First equation, second equation, the point of intersection is a solution. If you did the second equation first and then did the first equation, your point of intersection is still exactly the same. So swapping rows does nothing to the answer, as long as you swap the right-hand sides as well. You take the entire second row and make it the first row, and vice versa, you'll be fine.
I don't get like what the ones and zeros represent.
Nothing yet. When you convert this A to 1001, give me 2 minutes.
Okay. Wait, I don't know. Wait. But like, no, like, okay, you see how with the demonstration that you switch the ones and the zeros.
Mhm.
Why? It's because that's what I'm saying. Like, I don't
This
get
is
what the ones.
this is called as an identity matrix.
Okay.
An identity matrix, by definition, is a matrix that has 1 along the diagonal and 0 everywhere else.
So why you switched it when you switched the
Because if I switch this row up, I have to switch this entire row down.
But like, so say you had like in the book How would you know what 1 and 0 correspond?
It doesn't matter. I can take a matrix, and if I multiply it by its, or augment it by its inverse, and I perform a bunch of row operation, I'll get the inverse of this matrix. If I flip the rows and do the inverse, I'll get a different answer.
So it doesn't matter like what 1 goes to or 0 goes to?
It does matter. So
So how do you know?
you get the inverse. The inverse of this matrix is not going to be the same as the inverse of this matrix.
So like how do you know where the 1 is 0?
So you know what A looks like. Make I, so A is 10, 4, 4, 12, and put an I right next to it.
But how,
If you call this as A, so we can call this as B. So I can say this is A times I. I will take this and swap this. I will do 4, 10, 10, 4, 12, 10, 4. And I'll call this another matrix B. And if I still do 1, 0, 0, 1, the answer would be B inverse.
so I is 1 0 0.
I is always 1,
It's
0,
always
0, 1.
one.
That's
what
it.
I'm saying.
Yeah.
That's the-
I is always 1, 0, 0, 1. Okay. Okay.
Wait, yeah, I always.
I is an identity matrix. It's 1 along the diagonal and 0 everywhere else.
It has nothing to do with the physics at all.
Nothing at all. I is always I.
I feel like it would be like I feel like if 10 could be a pivot, that would be 1, and then if 12 could be a pivot, that would be 1, and then the rest that is below that is 0. That wouldn't that be the same thing?
We'll do it both ways.
Okay.
We'll finish this and then we'll come back and do it your way. Okay. Let's continue with the pivoting operation. Okay, so now what's the pivot?
Where? For that one?
No. So we,
10.
10.4. What's the multiplier?
4 over 10.
Yeah, that's good. Yeah, 4 over 10.4 is good. Okay. And no, it's the other way around.
Oh, it's 10.4.
10.4 over 4.
But
And row 1 equals row 1 minus m times, no, it is 4 over 10. M times, yeah, it is 4 over 10.4, I'm sorry. M times row 2. Okay? So, we are not changing row 2, so we will write it as is. Okay, let's change row 1. Okay, so
why are we doing this again? Oh, because we need another 0.
we are going to make this 0. So we're going to change all 4 numbers. We're going to make these 2 4 zeros. We're going to make this 10 as 1 and this 12 as 1. Yeah. Okay. So row 1, this quantity here, tell me what that should be. What's the new row 1 is? What's the old row 1? Minus 10.4 times 0. So that remains unchanged. That simply stays as 10. From here, right? Row 1,
Yeah.
the new row 1 equals the old row 1 minus m times row 2. How about this guy here? The 4 minus 4 times I'm sorry. Yeah, 10.4 over 10.4 times 10.4. And the answer is 0. Now we have to do the same thing to these two guys here. Okay, so what do we have? Row 1 is 1 minus 4 over 10.4 times
No, times negative 4 over 10.
10. So, okay. And could somebody tell me what that number is, please? It should be positive, right? It should be 1 point something.
It's 1.154.
1.154. And how about the last guy here? 0 minus 4 over 10.4 times 10.4. Oh, I'm sorry. Negative 4 over 10.4. Okay. We don't make 10 the pivot. What we do is we simply divide row 1 by 10.
Can I ask why you didn't make 10 the pivot?
Because I took 10 as a pivot and made everything 0 below that.
When was that? Was it
The first step was take 10 as a pivot and make the number below that 0.
trying to make 4 zeros? So
Yeah.
that's why you took, okay.
I took this as the pivot and I made this 0.
So everything above it is there?
Yeah, so below the pivot 0, above the pivot 0. And now we're going to make the pivots 1 by simply dividing. So what we have is 10, 0, 0, negative 10.4, augmented with 1.154. Could somebody tell me what this number is in decimals, please? 4 divided by 10.4? Where did I get the negative sign from?
Is it positive or negative?
This is positive, but this one is going to be negative. Yeah.
It's 0.385. I would just say 5 because
That's good. 4 something. Okay. This guy is negative 4/10, negative 0.4, and this guy is 1. Okay. I'm going to perform 2 operations at once instead of doing it 2 separate steps. I'm going to say row 1 equals row 1 divided by 10, and row 2 equals row 2 divided by 10.4. No, simply dividing each row by a number, both sides of the equation. Okay, so if I divide this by 10, what will I get? I'm dividing the entire first row by 10. Okay? And if I divide this by 10.4, what do I get? You tell me what this number is? 0.4 divided by 10.4? I'm dividing everything by 10.4, right?
Oh, to get that, okay, I get it.
Negative 0.0385. Okay. And 1 divided by 10.4. Okay? This is now your A inverse.
For many purposes, we get that A inverse.
Yeah. So, A times x equals b. If I wanted x, I will multiply A inverse times b. Now let's do that and find our x. What is my A inverse? Could somebody help me with that, please? 0.1154. Are we making a mistake here with 5.8 and 8.5? Or they're both 8.5s? I put 5.8 here. Okay?
And then 0.096.
So x equals A inverse times b. b is 6, 9. So how do you multiply these two matrices now? So x is nothing but I1, I2, right? That's what we call x equals. So what do you get? 6 times? Okay. Plus or minus? Plus or minus? You're multiplying these two matrices, right? How do you multiply matrix? You take the row and you line it up against the column. So you get 0.1154 times 6.
Oh, minus.
Thank you. Minus 0.0385 times 9. And what's the second entry? Okay. Okay. Six. Does it match our answer?
Yeah.
So we got the inverse right.
Like in the book, they do it.
Yeah. So I will talk about the book in the next class in the assignment. All right. So this is.
But I found the book easier.
You find the book easier? I'll do the
Maybe
book
just
way.
Switch these and negate them. And then
Yeah, we'll do the book way too. Yeah. So the reason why I do this is because it helps you understand the process better. We'll take care of the book and how to do well in the exam on Wednesday. But see, today's class is purely fun with numbers. So enjoy this, then we'll worry about the homework and the book on Wednesday. Okay? So what I wanted to teach you in today's class was many ways to look at exactly the same problem. So in high school, you did substitution. All right? So we don't do that now. No, today's class we saw 4 ways you have not seen before. The row picture. You draw 2 lines and where it intersects, you find the coordinates, that's an answer. The column picture. Some amount of one arrow plus some amount of another arrow takes you to the point where you want to go, which is 6, 9. That's the second picture. The third picture is the elimination. So you have a matrix and you convert it into its upper triangular matrix, which means you make one of the numbers below the pivot, or if it's bigger than a 2 by 2 matrix, all numbers below the pivot go to zeros. And what will happen is the very last equation will give you directly the answer. It'll have all zeros and only the last number non-zero, last coefficient non-zero, and you can find your I2 or Y or whatever that is. Then you can substitute back and find everything. That's the third way. The fourth way is the inverse. So I want you to walk out of the class having a very clear picture of the four things that the same set of equations represent. I can take two equations, I can write them in matrix form, I can get a row picture, I can get a column picture, I can do an elimination method to find the solution, and I can do an inverse matrix method to find the solution. Okay? Yeah.
What is the best way to do it? Like
None of
always
these.
use-
None of these.
None of these?
None of these.
Oh, none of these.
None of these.
Oh.
The best way to do it is, so the one that's mostly used in engineering practice is the elimination way. Okay? And even that is not very efficient because it takes a lot of computer time. There is another way which you will learn in your junior year as well.
And
So-
that's an easier way?
Yeah, what we do is we take a guess at the answer.
Okay.
All right, and we say, let's say the answer is 0, 0. And we will see how far we are. We'll substitute that into the original equation. If you substitute the correct answer into the equation, your left-hand side will be equal to the right-hand side. If you substitute the wrong answer, you will get a number, and the difference between the left-hand side and right-hand side will tell you how far off you are from the correct answer.
By just that much, or?
By a certain amount. Then based on that, we will make an updated guess. We will guess, and get to the right answer. Okay, so that's practical. But this is also used very often in engineering. The converting a matrix into the upper triangular matrix, that's very commonly used in engineering practice. Yeah.
How often is the guessing used?
Sometimes you get to the stage where you have this giant matrix and then you have to use elimination. We use guessing to avoid even going into the giant matrix stage. So you go directly from the equation to the guess. And when you do that, you use the guessing method. Sometimes you are forced to assemble a giant matrix. And when you do that, you don't have any other choice but to go via elimination. Okay? So all this process of getting your pivots and making all of them 0, in your junior year, when you take linear algebra, I will teach you how to write a computer code to do all that. And you can, just like that, solve a million by million matrix as quickly as you solve a 5 by 5 matrix.
Well, you can type out each one of those ones in the matrix, though, right?
It doesn't, we simplify everything. You normally don't sit and type out a million lines of code either. So yeah, so we simplify everything.
You said that the guessing method would be better.
Mhm.
Like, how would that be better?
Computationally better. So each addition, multiplication, division that you do is one query to your processor, to your microprocessor. The more questions you ask your microprocessor, the more time it takes to respond. So what you do is you do the elimination and you calculate the total number of multiplications and divisions. So for example, how many multiplications did we do here? There's one multiplication and one addition to make this go to 0. Then another multiplication and an addition. So there are 4 multiplications and 4 additions for one pivot. We have 2 pivots, 8 multiplications and 8 additions. Then we're converting these 2 into ones by multiplication. So another 8 multiplications for each one of those. So you have 16 multiplications and 8 additions. That's 24 for a 2 by 2 matrix. So if you had a 3 by 3 matrix, how many multiplications and additions, etc. So you would count all this and you'll get an estimate of how many times you do multiplication and division. If you could do something to reduce the number of multiplications and divisions, you have a better method. That's what we do. We look for ways to minimize the number of operations the computer has to perform. That way it gives you the answer faster. All right? So don't worry about the homework. Go read your book and see if you can use these 4 tools to understand the problems better. So when we come back, I will use exactly the language that's used in your book. That way you're more comfortable with it. And we'll do the homework problems as well. Okay?
And you'll go over like the Kramer's rule and stuff like that.
I'm sorry?
You'll go over the Kramer's rule that's in the homework, right?
We'll do all that, yeah.
Are we done for now?
That's it, right? Class ends at 3:50? Yeah, 5 minutes.
Did you go over the last problem on the test stuff?
The last problem on the test. Okay. So that's the problem. The first question was find angles theta 1 and theta 2. Okay. So this is theta 1, this is theta 2. So theta 1 is arctan 1.5 divided by 18. Theta 2 is arctan 1.5 divided by 8. Use the positive xy coordinate system shown in the figure and write tensions T1 and T2. Oh, let me write your names down. Could you, here, how about you write your names on a sheet of paper? Thank you for reminding me. Using positive xy coordinate system shown in the figure, write tensions T1 and T2 and the weight in standard vector notation using I and J. Okay, so you know these 2 angles now. So what I can do is, I'll use another color here. I can take this T2 and write it as T2 cosine theta 2 and T2 sine theta 2, like so. And I can also write the T1 as T1 sine theta 1 and T1 cosine theta 1. Okay? And X is I and Y is J. Okay, so they're asking you to write the unit vectors in terms of I and J. So the ith component is T cosine theta 2 minus T cosine theta 1 equals 0. And the jth component is this is T1, this is T2. Okay. So T2 sine theta 2 plus T1 sine theta 1 equals 1.5. That's the answer to part 2. Okay, so you can again do linear algebra and solve this. So you can write it like this. So cosine theta 2 minus cosine theta 1 and sine theta 2 positive sine theta 1 T2 T1 equals 0, 1.5. Then you can solve this. If you didn't know linear algebra, which you were not expected to in the first test, what you would do is you have this equation T1 plus T2 plus W equals 0. Okay, so you would simply find out what T1 is from here, substitute into the equation T1 plus T2 plus W, and then solve for T1 and T2.
How do you solve that in matrix?
How do you solve this in matrix?
Yeah, when you have too many unknowns.
No, you know theta 1 and theta 2. You found that that's the answer to part 1. So you would know all these four. You'd simply have to find T1 and T2. Okay?
That was a substitution method to find.
Yeah. Yeah, if you didn't know linear algebra, you would do it by substitution. All right.
So you solve for T1 or T2, and then just solve for T2.
Say that one more time.
You couldn't have solved for T1 or T2 through the substitution method?
Yeah.
You had to pick one or the
No. Did you put your name in here?
Oh, I have no idea.
You too. See you on Wednesday.